Dear students, today I am going to discuss oxidation number, which we are using abbreviation ON in chemistry. It is defined as the charge which an atom or an ion appears to have in its compounds when electrons are counted in accordance with the following arbitrary rules, which are quite helpful. First is electrons shared between two unlike atoms are counted with the more electronegative atom. For example, the electron pair shared between hydrogen and chlorine in hydrogen chloride is counted towards chlorine atom to give it a -1 charge, and consequently the hydrogen atom gets +1 charge. Hence, oxidation number of hydrogen and chlorine are respectively +1 and -1. Because in hydrogen chloride, chlorine is more electronegative. Second point is electrons shared between two like atoms are divided equally between the sharing atoms, and so they develop no charges, and hence the oxidation number of constituent atoms is 0. For example, oxidation number of oxygen in O2 is 0. So also that of hydrogen in S2 or Cl in Cl2. That means all these molecules, whether it is diatomic or triatomic or tetraatomic or any other, if it is formed of like terms, then the oxidation number of that atom will be 0 in that molecule. As in N2, nitrogen oxidation number is 0. In hydrogen molecule, hydrogen atom oxidation number is 0. In fact, every substance in the elementary state is given the oxidation number of 0. In water, S single bond O single bond H, when the shared pair of electrons should count towards the central O atom, more electronegative element, O atom acquires the oxidation number of -2, and each hydrogen atom has +1. In general, the following rules are very helpful in order to assign the oxidation number of different atoms or ions. A. That means the first point. In the elementary state or uncombined state, the atoms are assigned an oxidation number of 0. B. In compounds, the oxidation number ON of fluorine is always -1, and that of alkali metals like lithium, sodium, potassium, rubidium, etc. is +1, and that of alkaline earth metals like beryllium, magnesium, calcium, strontium, etc. is +2. Third point says oxidation number of hydrogen in compounds is generally +1, except in case of metallic hydrides, wherein its oxidation number is -1. Okay, next point D is fourth point. Again, in compounds, the oxidation number of oxygen is generally -2, except in F2O, wherein its oxidation number is +2. It means oxygens. Oxygens oxidation number is +2. Because that of fluorine must be -1. Again, in hydrogen peroxide, S single bond O, single bond O, single bond H, that is H2O2. Each of the oxygen atoms has an oxidation number of -1 and each of hydrogen atom +1. Because the electron pairs between each oxygen and hydrogen pair is counted towards oxygen atom, and the electron pair between oxygen atom themselves being the equally shared. Fifth point, the last E, is in neutral molecules. The sum of oxidation number of all the atoms taken together is 0, whereas the ions possessing positive or negative charges, the sum of the oxidation number of all the atoms is equal to the net charge on the ion. Now we are taking 3 examples. The first example is KMnO4 is a neutral molecule, whereas MnO4 2 minus, MnO4, that is a magnet, is an anion possessing 2 negative charges. Now we have to find oxidation number of manganese in potassium permanganate KMnO4 and acid radical MnO4 as well. Now let X be the oxidation number of manganese in KMnO4, that is potassium permanganate, as well as MnO4 as an anion. So you find in KMnO4, K is potassium, its oxidation number is 1, so 1 into 1 plus. Manganese, we have to find out, it is single atom, so X only we have written, plus oxygen 4 atoms and its oxidation number is -2, so -2 into 4, this is equals to 0. Net oxidation number is 0 since KMnO4 is a neutral molecule. So it becomes 1 plus x minus 8 equals to 0. This implies x minus 7 equals to 0. That is x equals to 7, and therefore oxidation number of manganese in potassium permanganate, that is KMnO4, is +7. Now in MnO4, which is an anion, manganese oxidation number we have to find out. It is single, so we have supposed x plus, and oxygen is 4 atoms, and oxygen's oxidation number is -2, so -2 into 4, and that is equals to -2 because its net charge is -2. That's why net charge we have written -2. Also we get x minus 8 equals to -2. This implies x equals to -2 plus 8, that is x equals to +6. And therefore oxidation number of manganese in MnO4 anion is +6. Now, in manganese dioxide, that is MnO2, which is a neutral molecule. It is neither an anion nor cation. It is a neutral molecule, manganese dioxide. And we have to find oxidation number of manganese. So, supposing oxidation number of manganese be X, and here manganese is a single atom, that's why X plus, and oxygen, you know, oxidation number of oxygen is -2, and here 2 atoms are there, that's why -2 into 2, so X plus -2 into 2, that is equals to 0. 0 because manganese dioxide, that is MnO2, is a neutral molecule. So X minus 4 equals to 0. Therefore X equals to +4. So we find oxidation number of manganese in manganese dioxide is +4. So in 3 different examples we find that in potassium permanganate, manganese oxidation number is +7. In MnO4 anion, Its manganese oxidation number is plus 6, and in manganese dioxide MnO2, oxidation number of manganese is plus 4. Thank you. In this way, you will find the oxidation number of different compounds. Thank you. If you like, please share and subscribe.